What's up everyone? Welcome back to VC Tech. In today's video, we are going to be talking about multi-area OSPF as we have right here. What it is, why it exists, and why it is used in real enterprise. If you've already understood basic OSPF, or you're confused about areas, area 0, and why engineers split network into multi-areas, this video is for you. By the end of this video, you will clearly understand how multi-area OSPF work, why single areas OSPF doesn't scale, and how networks are designed in real world. With that being said, let's have a bit of a knowledge about what OSPF means and how it works. For this is why OSPF area. Because single area OSPF doesn't scale well for large enterprise, for large network. Large network costs high CPU and memory usage, as well as link states database. However, multi-area OSPF improve performance and stability. How multi-area OSPF works: network are divided into multiple areas, and area 0 is the backbone of all the areas. The area border router that connects all other areas, maybe from area 1 to area 10, they all connect back to area 0. The benefits of multi-area OSPF is one, for its fast convergence, and it has a smaller routing table because all the networks are divided into smaller areas, and better scalability for enterprise and ISP standard design. So with that being said, guys, let's head over to our Cisco packet tracer where we can configure multi-area OSPF on a router. So for this tutorial, we are going to be using 4 routers, and this router is going to be connecting area 1, this is area 1 router, and area 2 router to area 0 router. So for this topology, this is going to be serving as area 0, while this is going to be connecting area 1 and area 2. Now for this tutorial, we are going to be talking about the benefits of the areas. So this is area 0, and this is area 1, and this is area 2. Now the reason why we are doing this is for the network not to be congested, so the link state database will not be flooded, and for the network to work smoothly. Now we are going to configure for area 0 first. We are going to configure OSPF for area 0 before we move to the other areas. So it's the same from how we configure OSPF from the previous video that we made. It's just the areas this time will be different. If you remember, we talked about area 0. This time around we'll be talking about other areas. So router OSPF wants the process ID to be 10, and always remember to assign a router ID. So for this is going to be taking 1.1.1.1. And we also want to specify the networks that are directly connected to that network. We're going to say network 192.168.1.0 with the wildcard bits. Remember guys, 0.0.0.0.255 area 0. So this was the same configuration we did from the previous video when we configured OSPF. And guys, this is the network of 192.168.1.0 that we just added to our OSPF area. Let's also do for the second network, which is network, and that's 10.10.10.10.0 with a wildcard bit of 0.0.0.255 area 0. So guys, this network right here is the backbone of the multi-area OSPF. Now let's configure OSPF on this router and assign its area to it. So router OSPF with the process ID of 10, with the router ID also of 1.2 or 1.1, excuse me, 1.1.1.2. We want to specify the networks that are directly connected, which is 192.168.2.0 with a wildcard bit of 0.0.0.255 area 1. We also want to do the same for the second network, which is, that should be 10.10.20.0 with a wildcard bit of 0.0.0.255 area 1. So guys, this is area 1. As you can see, it has its own link state database. It also has its own CPU. So the network is going to be scalable and stable, as we are also going to create another link state database for this network, and we've already created for area 0, we've created for area 1. Now let's create for the last network. Now the benefits for having smaller areas in the network is, 1, it provides a smaller routing table, as it reduces the link state advertisement traffic. It is also fast and problem containment. You see, if there is any problem, now we know where to go and tackle the problem, if it's in area 1 or area 2 or area 0. Now let's configure OSPF on the router OSPF with the process ID of 10 and a router ID of 1.1.1.3. We want to specify the networks, which is 192.168.3.0, the wildcard bit of 0.0.0.255 area 2. We also want to specify the second network of 10.10.10.30.0, 0.0.0.255 area 2. Now let's create OSPF on the last router. To enable that router, connect multiple areas. So we say router OSPF with the process ID of 10 and router ID of 1.1.1.4, and we want to specify all the networks that are directly connected to them with their areas. So we have 10.10.10.0 with a wildcard bit of 0.0.0.255. Remember guys, this is area 0. We have the network of 10.10.10.2 and 10. We also have here 10.10.10.1. So it means this network is connected to 10.10.0. So this is the area 0 network. That is why we have to specify area 0 right here. We are also going to do the same. However, we'll just go here and make this 20. And we check on this router and we can see 10.10.20.1. So 10.20 is on this network, which is area 1. And we specify, oops, oh well, it has 10 dots. No, we just have to do that again. But as you can see guys, it has formed neighbor with 1.1 in 1.1 router, the router ID 1.1, which is this router over here. This router over here has a router ID of 1.1 and it has formed neighbor, as well as this router has formed neighbor with 1.4. This router is 1.4, as you can see here. And we also need to do for this other interface. So this should be 10.20 20.0, and the area should be area 1. We are also going to get neighbor with this router. Let's also do the same for the last router. So this should be area 2, and this should be area 2, and this should be 3. As you can see, guys, area 1 has already formed neighbor with area 4, as well as area 3 has formed neighbor with area 4. As if we go ahead and check, this is the area 2 router, and it has formed neighbor with the 4th router, the router connecting area 0 to all the other areas. And on the area 1 network, you can also see it has formed neighbor with area 4, which is directly connected to area 0 network. Now guys, this is how we configure OSPF area and how we link them back to the area 0 network. Let's go ahead and ping from one local area network to another local area network. So we'll say ping 192.168.2.1. Let's ping the default gateway, and yes, we gain connection. Let's also ping 3.1 network. We are also able to ping 3.1 network because we've configured OSPF and multi-area network. So guys, we've configured OSPF on all the areas, and not just OSPF. We've configured OSPF with different areas. Now let's try to troubleshoot and see what we did. So do show IP OSPF. As you can see, it's telling us that we are using OSPF with the process ID of 10. As you can see right here, process ID of 10 with a router ID of 1.1.1.3. It also shows that this is area 2, meaning this is not the ABR, area border router. And as you can see here, number of interfaces in this area is 2. So there are 2 interfaces that are connected. Let's also check for OSPF neighbors from this router. Let's check for OSPF neighbor. So do show IP OSPF neighbor. So our neighbor is 1.1.1.4. That is because we are directly connected. However, if we check from this router, it's going to show you that we have 3 neighbors. Do show IP OSPF neighbor. You can see we have 3 neighbors that are directly connected to this router. Let's also check do show IP OSPF and see if this is our ABR. So as you can see, guys, this one is saying our process ID is OSPF 10 with a router ID of 10 of 1.1.1.4. Now there is something unique about this that is not here. You can take your time to scrutinize what we have here and see if you're going to find it. However, I'm going to tell you real quick. So on this router, there is nothing like this is an area border router. If you check thoroughly, so this is a process ID support only single. If you check everything, there is nothing like an area border ID. However, let's check on this router. On this router, we have our routing process, which is OSPF, and we also have this right here. It is an area border router. If you remember, guys, an area border router is a router that connects area 0 and other areas. So this router over here is connecting area 0 and area 1 and also area 2. Now guys, this is how we configure multi-area OSPF on a router. Remember, the area 0 is always the backbone of the OSPF areas. If this video helped you understand how to configure multi-OSPF area in a network, why not give me a like and subscribe to this video? Because next we'll be talking about default static route. Where does our data go to when it doesn't know where to go to? Thank you guys, and see you in the next video. Also, like and subscribe.